Fundamentals of welding for jointing and assembly processes. In overview of welding technology, we consider the processes that are used to join two or more parts into an assembly entity. These processes are labeled in the lower stem. The term joining is generally used for welding, brazing, soldering, and adhesive bonding, which from a permanent joint between the parts, a joint that cannot easily be separated. The term assembly usually refers to mechanical method of fastening parts together. Some of these methods allow for easy disassembly, while others do not. Mechanical assembly is covered in later. Brazing, soldering, and adhesive bonding will be discussed. In jointing is a material jointing process in which two or more parts are coalesced at their contacting surface by suitable applications of heat and or pressures. Many welding processes are accomplished by heat alone, with no pressure applied. Others of combination of heat and pressure are still others by pressure alone, with no external heat supplied. In some welding processes, a filtered material is added to facilitate coalescing. This is a coalescing. The assemblage of parts that are joined by welding is called weldment. The welding is the most commonly associated with metal part, but the process is also used for joining plastic, and this focus on metals. Welding is relatively new process. It's a commercially and technology important drivers from such as weldings provide a permanent joint. The weld parts become a single entity. The weld joint can be stronger than the parent materials if a filler material is used that has strength properties superior to those of the parents, and if proper welding techniques are used. Welding is usually the most economic way to join components in terms of material usage and fabrication costs. Alternative mechanical methods for assembly require more complex shape alteration, such as drilling of holes, and additional of fastener, such as rivets or bolts. The resulting mechanical assembly is usually heavier than a corresponding weldment. The welding is not restricted to factory environment. It can be accomplished in the field. Although welding has the advantage indicator of, it also has certain limitations and backdoor. Most welding operations are performed manually and are expensive in terms of labor costs. Many welding operations are considered skilled trades, and the labor to perform this operation may be scarce. Most welding processes are inherently dangerous because they involve the use of high energy. Since welding accomplishes a permanent bond between the components, it doesn't allow for convenient disassembly. If the product must occasionally be disassembled, for example, for repair or maintenance, then welding should not be used as the assembly method. Welding joint can suffer from certain quality defects that are difficult to detect. The defect can be reduce the strength of the joint. So the origin of the welding, although origins is considered relatively new, but is tracked. It can be traced to ancient times, around 100 years before century. The Egyptians and the author in the eastern Mediterranean area learned to accomplish forged welding. It was naturally extent of hot forging, which they used to make weapons, tools, and other implements. Fork weld articles for bronze have been recovered by archaeologists from the pyramids of Egypt. From these early beginnings, though the Middle Age, the blacksmith trade developed the art of welding by hammering to a high level of maturity. Welded objects of iron and other material dating from this time and have been found in India and Europe. It was not until the 800s that the technologies foundations of modern welding are established. Two important discoveries were made, both attributed to English scientist Sir Humphrey Davy, the electric arc and acetylene gas. Around 1901, around 1801, Davy observed that an electrical arc could be struck between two carbon electrodes. But however, not until the mid 18th, when the electronics generator was invented, did electrical power became available in amount sufficient to sustain arc welding. It was Russian Nikolai Benados, working out of laboratory in France, who was granted a series of patents for carbon arc welding process, one in England in 1889, 85, and another in the United States 1887. By the turn of century, carbon arc welding had become a popular commercial process for joining material and metals. Bernadottes' invents seem to have been limited to carbon arc welding, but in 1892, an American named Charles Coffins was awarded a U.S. patent for developing an arc welding process utilized a metal electrode. The unique features was that the electrode added filler metals to the weld joint. The carbon arc process does not deposit filler. The idea of coating of the metal electrode to shield the welding process from the atmosphere was developed later, with the enhancements to the metal arc welding process being made in England and Sweden start around 19th century. Between 1885 and 19th century and 1900, several forms of resistant welding were developed by Thomson's. This includes spot welding and seam welding, two joining method widely used today in sheet metalworking. Although David discovered ethylene gas early in the 18th century, oxide-fuel gas welding required the subsequent development of torch for combining ethylene and oxygen around 1900. During the 1890s, hydrogen and natural gas were mixed with oxygen for welding, but excellent flame achieved significant higher temperature. This time welding process, arc welding, resistant welding, and oxy-fused gas welding constitutes by far the majority of welding operations performed today. Overview of welding technology. Welding involves localized. Welding involves localized coursing coalescing, or joining together of two metallic parts at their flying surface. The flying surface are the part surface in contact or close approximately that are to be joined. Welding is usually performed on parts make the same metal, but some welding operations can be used to join dissimilar metals. Type of welding process: some 50 difference. Some 50 difference of welding operations have been cataloged by American Weld Society. They use various type of combinations of energy to provide the required power. We can divide the welding process into major groups: fusion welding and solid state welding. Fusion welding. Fusion welding process use heat to melt the base metal. In many fusions welding operations, the filler metals is added to molten pool to facilitate the process and provide bulk and strength to weld joint. A fusion welding operations in which no filler metals is added is referred to as an autogenous weld. The fusion catalog includes the most widely used welding processes, which can be organized into the following general group. Initials in parentheses are designed for American Welding Society. Arc welding. Arc welding refers to a group of welding process in which heating of metals is accomplished by an electronic arc. Some arc welding operations can also apply pressure during the process, and most utilize filler metals. And that is arc welding. We call it AW. What about resistant welding? RW. Resistant welding achieves coalescence using heat from electrical resistance to flow of a current passing between the failing surface of two parts held together under pressure. So this is about basic of arc welding. Between the welding, during the welding, the base metal is melted and the filler metal is added to the molten pool. And the complete weldment. There are many variations of arc welding process. So let's look at oxy-fuel gas welding, or FW. Oxy-fuel gas welding, or FW. This joining process can use an oxy-fused gas, such as a mix of oxygen and ethylene, to produce a hot flame for melting the base metal and filler metals, if one is uses. Other fusion welding process. Other welding processes that are used that produce fusions of metals joined include electron beam welding and laser beam welding. Certain arc and oxy-fused processes are also used for cutting metals. Next would be the solid-state welding. Solid-state welding refers to the joint process in which coalescence results from application of pressure alone, or combination of heat and pressure. If heat is used, or the temperatures in the process is below the melting point of the metals being welded, no filler metal is utilized. Some representations welding processes in this group include diffusion welding, DFW, diffusion welding, DFW. Two processes and two surfaces are held together under pressure at an elevated temperature, and the parts coalesce. So it's a colorless and a coalescent. Colorless is achieved by the heat of friction between two surfaces. That is friction welding. And diffusion welding is two phases are held together under pressure and elevated temperature, and apart and coalesce by solid state fusions. Next would be ultrasonic welding, USW.
Coalescence.
Coalesce and coalescence. Coalescence means the joy or merging of elements to form one mass. And coalesce is came together is the verb came together to form one mass of whole. Coalesce is a verb, part coalesce, and the part coalesce. So coalesce is achieved by the heat and ultrasonic welding. Yeah, but the red pressure is applied between two parts, and an oscillation motions at ultrasonic frequency is used in a direction parallel to contacting surface. The combinations of normal and vibratory force results in shear stress that remove surface films and achieves atomic bonding of the surface. So this describes the various welding process in greater detail. So we're going to look more on this. So next will be the welding and commercial operations. Principal application of welding are constructions such as building and bridge, piping, pressure vessels, boiler, and storage tanks, shipbuilding, aircraft, and aerospace, automotive, and railroad. Welding is performed in a variety of locations and a variety of industries, owning to it versatilities as an assembly technique for commercial products. Many welding operations are performed in factories. But however, several of the traditional processes such as arc welding and oxyfused gas welding use equipment that can be readily moved. So these operations are not limited to the factory. They can be performed at construction site, in shipyard, at a customer plant, and in automotive repairing shop. Most welding operations are labor extensive. For example, the welding you perform is skilled labor is called welder, who manually control the part of placement of the weld to join individual parts into the large unit. In factory operation in which welding is normally performed, the welder often works in a second worker called a fitter. It is the fitter's job to arrange the individual component of the welder period prior to making the weld. The welding fixture and positioner are used for this purpose. Welding fixture is a device to clamp or for clamping and holding the component in fixed position for welding. It is custom fabricated for the particular geometry of the weldment, and therefore must be economically justified on the basis of the quantities of assembly to be produced. The welding positioner is a device that holds the part and also moves the assembly to the desired position of welding. This differs from a welding fixture that only holds the parts in a single fixed position. The desired position is usually one in which the weld part is flat and horizontal. First, safety issues. Welding is inherently dangerous to human worker. Strictly safety precautions must be practiced by who perform these operations. The high temperature of molten metals in welding are obviously dangerous. In gas welding, the fuels, ethylene, are fire hazards. Most of the process use high energy to cause melting the part surface to be jointed. In many welding processes, electrical power is source of thermal energy, so there is a hazard for electrical shock to the worker. Certain welding processes have their own particular peril. Yeah, so dangerous perils, their own particular peril. Certain welding processes have their own particular peril. Perils. Yes, in arc welding, for example, ultraviolet radiation is emitted that is dangerous to human vision. A special helmet that includes a dark viewing window must be worn by the welder. This window filters out dangerous radiations, but it's so dark that it hardens the viewer virtually blind, except when the arc is stuck. The spark spatter. So say sparks or spatters of molten metals, smoke and fume add to the risk associated with welding operations. Ventilation facilities must be used to exhaust the dangerous fumes generated by some of the flex and molten metals used in welding. If the operation is performed in an enclosed area, special ventilation suits or hose are required. And in automation in welding, because this is a hazard of manual welding, is effort to increase productivity and improve product quality, various forms of mechanicalizations and automation have been developed. So it's a machine welding can be defined as mechanicalized machine welding can be defined as mechanized welding with equipment that perform the operation under the continuous supervision of the operations. This is normally accomplished by welding head that is moved by mechanical means related to the stationary work, or by moving the work related to a stationary welding head. Human worker must continuously observe and interact with the equipment to control the operations. If the equipment is capability of performing the operation without adjustment of control by the human operator, this is referred to automatic welding. A human worker is usually present to oversee the process and detect variations from of normal conditions. What distinguishes automatic welding from machine welding is a weld cycle controller to regulate the arc movement and piece or workpiece positioning without continuous human attention. Automatic welding requires welding fixtures and or positioner to position the work related to the welding head. It also requires a high degree of consistency and accuracy in the components part used in development. For this reason, automatic welding can be justified only for large quantity productions. In robotics welding, an industrial robot or programmable manipulators is used to automatically control the movement of welding head related to the work. The versatile reach of the robot arm permits the use of relatively simple fixtures, and robot's capability to be reprogrammed for new part configurations allow this form of automations to be justified for relatively low production quantities. A typical robotics arc welding cell consists of two welding fixtures and a human filter to load and unload part, while the robot welds. In addition to arc welding, industrial robots are also used in automobile final assembly plant perform resistant welding on cars body. So it's about arc welding, and it's said about the another welding, just arc welding and resistant welding. The weld joint is a solid connection between two pieces called weld joint. Weld joint is junctions of the edge or solid or part that have been joined by welding. This section covers two classifications related to joint part. One, type of joint, and two, type of joint used to join the piece that form the joint. Okay, so type of joints. There are 5 basic types of the joint that bringing two parts together for joining. The 5 joint types are not limited to welding. They are applied to other joining and fastening techniques as well. With reference, so butt joint, corner joint, lap joint, T-joint, edge joints. In this joint, butt joint, the part line in the same place and joint in the edge. The corner joint, the part is a corner joint is right angle, a joint at the corner of the angle. And that is the lap joint, T joint, and edge joint. Type of weld. Each of the process joint can be made by welding. Is it appropriate to distinguish? Okay. It must distinguish, okay, between the joint type and the way which is welded. The weld type different among the weld type are in geometry, joint type, and welding process. Yes, the filler weld is used to fill in the edge of the blade created by the corner, lap, and the T-joints. Yeah, the filler metals is used to provide a cross-section approximation the shape of the right angle. It is the most common weld type in arc and oxyfuels. As fillet weld is the common weld type in arc and oxyfuel welding because it requires minimum edge operations. The basic square edge of the bars are used. The fillet weld can be single or double, and it can be continuous or intermittent. Is yes, continuous and intermittent is mean not continuous, discontinuous. A weld along the entire length of the joints or with unwelded space among the length. Okay, that is the welding. Groove welds are usually quite the edge of the part that shape into the groove to facilitate weld penetrations. Yeah, penetration just mean it's just well along. The groove shape includes square below, yes, and something you can find for informations. To find some picture for that, and in the some picture fill the filler metal is used to fill in the joint, usually by arc or by oxyfuel welding. Preparation of the part is beyond basic square edge, although requiring additional process. It's often done to increase the strength of the weld joint or where thicker parts are used to be welded, although most closely associated with butt joint. Groove welds are used on all joint types except lap. Plug welds and slot welds are used for attaching flat plate, as shown in the picture, using one or two holes or slot in the top part and then filling with filler metals. Spot welds and seam weld used for lap joint. Spot weld and seam weld used for lap joint. The spot weld is used in small fused sections between the surface of tube sheet or plate. Multiple spot welds are typically required to join the part. It is almost closely associated with resistant welding. A seam weld is similar to spot weld except it consists of a more or less continuously fused section between the two sheet or plate. So what would be the last thing would be the physics of welding. This is a lot of things to think about it. Although several coalescing mechanisms coalescent mechanisms are available for welding fusions, by far the most common means. In these sections, we consider the physical relationship that allow fusion welding to be performed. We first examine the issue of the power density. It's important, and then we define the heat and the power equations that describe welding process. So let's look at the power density. To accomplish the fusions, a source of high density heat energy is applied to the failing surface, and resulting temperature and sufficient and close localized melting of the base metals. So in the field of metals add and high density must be high enough to melt also. So that would be some formation comparisons of several fusions welding process on the basis of their power density, such as oxygen welding is the approximate power density about 10 watt per square millimeter, and I would need about 50, and resistant welding about 1000. Laser beam welding is about 9000, and electron beam welding is about 10,000. So it increases a lot of power needed. Also heat balance fusions welding. So this all depends on the quality of the heat required to melt. Given volume of metals depends on the heat to rise the temperature of the solid metals to its melting point, which depends on the metals uh, volumetric specific heat and the melting point of the metals and the heat of transfer from the metal form to solid to liquid phase at the melting point, which depend on the melting heat of fusions. The reasonable approximation of quality can estimate by some equations and some tables of the melting point of aluminums about 930 degree Kelvin. So increase in iron 10 1500, copper and is about 1000, nickel is higher about 1700, and about sheet about steel it depends on what kind of steel, low carbons, but it's approximate about 1700 degree Kelvin, and is quite the same as stainless steel. So it seems like aluminum is lower temperature and the steel is a bit higher. And the feature of joint fusion weld joint. So this is depend on the process and the strength of the metal that we combine the weld. So that is about the welding. So that would be an arc welding and resistant welding, and would be oxy-fuel gas welding, and be another thing like autofusion welding like electron beam, laser beam, electroslang, thermite, and solid state welding. So that would be some different welding. So we will focus on arc welding process.